Hello everyone. Today we are going to start lecture 03 of class 8 mathematics chapter number 2, which is linear equations in one variable. In this lecture we are going to talk about equations which are reducible to linear form. Now what do we mean by the word reducible? That is, when you look them in the first instance, you will find that they are not linear, and you may think that they cannot be converted into linear form and hence they will not have any solution. But when you start actually solving them, then you can find out that they can be reduced to linear form. That is, when you will solve them, you will find that they are actually linear equations in one variable. How do they look like? Let me give you an example. For example, an equation can be of the form ax plus b whole upon cx plus d is equals to m upon n. This is the general form of these types of equations, and you can clearly see that degree of numerator and degree of denominator is same, and hence the effective degree of the complete fraction is 0. That is not a linear equation, but you can solve them and you can reduce them to linear equations. For this we have two methods. First, you can multiply both sides by the denominator, okay, or the LCM of denominators, that is LCM of the denominators of the fractions on both the sides of equality, so that you can free this equation from fractions. Okay, so the first method involves that you should multiply both sides by cx plus d into n, right? Now why into n? Because LCM of cx plus d and n would be cx plus d into n, because we do not know what is n. Similarly, multiply both sides by, here cx plus d will cancel out each other, right? This will be cancelled out and n would be multiplied to ax plus b. This n would be multiplied to ax plus b, and here you can cancel out the n and this m will be multiplied to cx plus d. Now you can clearly see it has become linear equation in one variable, and we already know that these type of equations are those in which we have variable terms on both the sides. Okay, so you can further multiply it as an into x plus bn is equals to mc into x plus md, and then you can easily solve them. Now what is the second method? What you could have done is you could have cross multiplied it. Okay, so what do we mean by cross multiplications? We had this equation ax plus b whole upon cx plus d is equals to m upon n. Whenever you have these kind of situations, you can just cross multiply them. Okay, cross multiply simply means we know that if there are two factors, that is p, q, r and s, then you can just cross multiply like this. Okay, so n could be multiplied to ax plus b, that is you could write n into ax plus b, and this cross multiplication says that m should be multiplied by cx plus d. See, now you have saved this complete step and you have directly jumped to this step. So you can do by either of the method, because they will give the same results. So these are the equations which are actually reducible to linear form. They do not look like they are linear equations, but when you try to solve them by cross multiplication or by multiplying both the sides by the LCM of denominators, you will find that these equations are actually linear equations in one variable, right? Let us solve a question relating to these equations with the real values of a, b, c and d, and let us see how do we solve it. Let the question be 2x plus 1 upon 3x minus 2 is equals to 9 upon 10. Now we have to solve it and find the value of x. So we can either use cross multiplication or we can multiply both sides by the LCM of this and this, that is 10 and 3x minus 2. Again, cross multiplication is easy. So we have 2x plus 1 whole upon 3x minus 2 is equals to 9 upon 10. Following the principle of cross multiplication, we will get 10 would be multiplied to 2x plus 1 and 9 would be multiplied to 3x minus 2, which will simply give us 20x plus 10 is equals to 9 into 3, 27x minus 9 into 2, 18, right? Again, we know the method of transposing 20x to RHS and minus 18 to LHS. Okay, so we are transposing 20x to RHS, so we will left with plus 10 and we have brought minus 18 from RHS to LHS, so it would be plus 18, right? Sign changes. Okay, here we have 27x, and since we transpose 20x to RHS, it would become minus 20x, right? So we have 28 is equals to 7x. Dividing both sides by 7, we will get 28 upon 7 is equals to x, which will simply give us x is equals to 4. And this is how we can solve the linear equation. Okay, and actually this equation was not linear, it was reducible to linear. So first we have to cross multiply, and then we have reduced it to linear equation, and then we know how to solve them. So x equals to 4 is the solution of the given equation. So it was a very easy question. Let us take another question. Now it do not have any real values. Okay, we do not know the value of a and b, so we have to solve the equation in terms of a and b. Okay, these are variable based questions in which the constant are also given in the form of a and b. Okay, so what we will do is, first of all we will write the equation as it is, that is x plus b upon a minus b is equals to x minus b upon a plus b. Now you can clearly see that if we cross multiply it, it can be reduced to linear form. So by cross multiplication, okay, you can also write the step here as by cross multiplication, right? You can write by cross multiplication. We have a plus b into x plus b is equals to a minus b into x minus b, right? So by cross multiplication you have a plus b into x plus b is equals to a minus b into x minus b. You can multiply them inside, so ax plus ab plus bx, ax plus ab, okay, ax plus ab into bx plus b square is equals to, again you can multiply them inside, you will get a into x, that is ax minus ab, then we'll multiply minus b to x, we'll get minus bx, and minus into minus, that is plus b square. So this is how we have multiplied them. Okay, then we'll bring all the terms of x on one side so that it can be easy to solve, and then we'll take all the constant to another side. So here we have ax plus bx. Now transposing ax, this ax on the LHS, we will get minus ax, and transposing this minus bx to LHS, we will get plus bx. So now we have all the terms containing x on the left hand side of the equality. Now here we have plus b square minus ab plus b square. We already have these two terms. Now transposing plus ab to the RHS, we will get minus ab. And transposing plus b square to the RHS, we will have minus b square. Now finally solving, we can see that ax minus ax would be 0, and bx plus bx will be 2b of x. Similarly here b square minus b square would get cancelled, and we will have ab and minus ab as minus 2ab, right? Again dividing both the sides by 2b, we get 2b upon x upon 2b is equals to minus 2ab upon 2b, right? So 2b will cancel the 2b, and we will have x is equals to 2 will get cancelled by 2, and b will get cancelled by b, so we will have x equals to minus a. So this is the solution of this given equation. Again what we did was, we first reduced it to linear equation in one variable, and then we solved it, right? Let us take another question on this particular method. Now this question simply states, again this you can clearly see that you will find that both the degree of numerator and denominator is same, that is the highest power of variable on numerator would be 2, because x into x would be x square. Similarly highest power of variable in the denominator would be 2. So you can cancel out these terms, and when you will divide them, you will find out that degree of numerator and denominator would be same. So effectively this should not be any kind of equation, but again we have to reduce it to linear equation, and then we will find out, okay, that what is the solution. that is the value of x satisfying the equation. Firstly, we have to create it in the form so that we can solve it. How do we do that? By cross multiplication. Simple. So we can have 4 plus x into 5 minus x equals to, now we can cross multiply this complete denominator to the right hand side, or you can solve it below, right? So for the time being, let us write the question as it is. Now we can multiply them. 4 into 5 would be 20, 4 into x would be 4x, and there is a minus sign. Similarly, x into 5 would be plus 5x, and x into x would be x square, which is minus x square because negative sign is there. Similarly, 2 into 7 is equals to 14. 2 into minus x equals to minus 2x, plus x into 7 equals to plus 7x, and then we have x into x square, okay, is equals to 1. Okay, by solving the equation we would find out that we have 20 minus 4x plus 5x, that is plus x minus x square whole upon 14 plus 5x minus x square is equals to 1, right? Again, cross multiplying both the sides, we have here 1 upon 1, so this denominator would be multiplied with the numerator, and by cross multiplication we have 20 plus x minus x square is equals to 14 plus 5x minus x square, because we have multiplied this denominator by 1. Again, now bringing all the terms related to x on one side, we have x minus x square already on the LHS. Okay, bringing 5x to the LHS will make it minus 5x, and minus x square will make it plus x square is equals to, here we have 14, taking 20 to the RHS will make it minus 20. So we will cancel minus x square with plus x square, and x minus 5x would be minus 4x, right? Minus 4x here would be 14 minus 20, that is minus 6. Dividing both sides by minus 4, we will get minus 4x upon minus 4 is equals to minus 6 upon minus 4. Again, cancelling out negative and common factors, we will get x is equals to 3 by 2. So this is how you solve a question involving these type of terms. Clearly it was looking like it was not linear. Also, all the terms of x were on the one side, we do not have anything on the RHS, but when we cross multiplied, we found out that the terms which are actually having x square are cancelling out each other, and the equation is becoming linear, right? Let us take one more question. Let us take this question in which we have all the terms in the denominator, and also there are terms on both the sides of equality, that is on the LHS and RHS both sides. Now there is a simple method to apply cross multiplication. You should have fractions on both the sides, but there should be only one fraction. Now we have two fractions, so firstly we can solve them, and then we can apply the method of cross multiplication, right? So let us do that. First of all, we write the equation as it is. 1 upon x plus 1 plus 1 upon x plus 2 is equals to 2 upon x plus 10, right? Taking LCM on left hand side, we will get x plus 1 into, we will get x plus 1 into x plus 2, right? This would be the LCM. So we have to multiply this by x plus 2, so we have to multiply numerator also by x plus 2, so it will be like this. Plus, to get this denominator, we have to multiply this by x plus 1, so we have to multiply numerator also by x plus 1, and here we have 2 upon x plus 1, x plus 10 as it is, right? Now adding these, we have x plus x, that is 2x, and 2 plus 1, that is 3. On the denominator part, we have x square plus x into 2, that is 2x, plus 1 into x, that is x, plus 1 into 2, that is 2. So we have this, and then we have this. Again solving them, we will get 2x plus 3 whole upon x square plus 3x plus 2 is equals to 2 upon x plus 10. Now clearly it is of the form where both the sides of the equality are fractions, so that we can multiply cross multiplications. We multiply x plus 10 with this numerator and x square plus 3x plus 2 with this numerator, right? So we will have by cross multiplication, by cross multiplication, comma, we have 2x plus 3 into x plus 10 is equals to 2 into x square plus 3x plus 2. Okay, so now we have to solve, we have to multiply them and we have to solve the equation. So let us multiply and solve the equation. We had 2x plus 3 into x plus 10. Okay, so we had 2x plus 3 into x plus 10 and then 2 into x square plus 3x plus 2, right? So we had 2x plus 3 into x plus 10 and we had 2 into x square plus 3x plus 2, right? Now we have to solve them, so let us solve them and find the value of x. 2x into x would be 2x square plus 2x into 10 would be 20x plus 3 into x would be 3x plus 3 into 10 would be 30 is equals to 2x square, 2 into 3 6x plus 2 into 2, that is 4, right? Now bringing all the terms of x on LHS, we will have, first of all we can solve them. 20 plus 3, that is 23x plus 30 is equals to 2x square plus 6x plus 4. You can clearly see that it is looking at it like it is a quadratic equation. When you transpose this 2x square on the LHS, this 2x square will get cancelled. So let us do that. Let us bring all the terms containing x on LHS. So it will be 23x. Now 2x square when transposed to LHS will be minus 2x square. 6x when transposed to LHS will be minus 6x. Then we are left with 4. Now we are transposing this 30 to RHS, so it would be minus 30. Clearly 2x square will be cancelled by 2x square and 23 minus 6 would be 17x. Here 4 minus 30 would be 26, which is minus 26, right? Dividing both the sides by 17, we will get 17x upon 17 is equals to minus 26 upon 17, which will finally give us x equals to minus 26 upon 17, which is the final answer of this question. And you can put x equals to minus 26 by 17 in this question and verify that LHS is equals to RHS. So that was all about equations which were actually reducible to linear form. In their original form they were looking like they are not linear, but when you solved them either by multiplying both sides of equality by their LCM of denominators or by cross multiplication, you found out that actually these are linear equations and they can be easily reduced to linear equation by applying some multiplications and divisions, right? So x equals to minus 26 by 17 is the solution of this equation. You can solve as many questions as you want in this method. Okay, so that was all about this lecture. Thank you for watching this lecture till end. I'll see you in the next lecture. Till then, goodbye.